All right, so now we get to matrix multiplication, which is probably the trickiest topic of matrices that we're doing in this course. So let's do a bunch of examples. So suppose we have a matrix, a 2x4 matrix. Okay, so it's going to be 2 rows and 4 columns. So let's say we have 1, 0, 3, -1, 2, 0, 1, 5. So this is a 2x4 matrix. And what I would like to do is multiply it by a multiply it by a 4x3 matrix. Now you might be saying, hold on, how is that possible? Well, we'll see. So we're going to do a 4x3 matrix. It's going to have 4 columns, and it's going to have 4 rows and 3 columns. So let's fill it out. All right, so here we have our 4x3 matrix. Let's just write it down. This is a 2x4 matrix. Okay, 2 rows, 4 columns. This is a 4x3 matrix. Okay, now this multiplication is actually going to work. It's possible to do, and the reason for that is that these inner numbers are the same. So in other words, the number of columns of the first matrix is equal to the number of rows of the second matrix, and that tells us that matrix multiplication is legal. It's defined here. So let's see how we do it. Okay, so it's not so straightforward. So the way it works is as follows. So first of all, the resulting matrix is going to be a 2x3 matrix. Okay, and it looks pretty weird, but I'll show you. It comes from here. It comes from this 2 and this 3. Okay, so that's where the 2x3 matrix comes from. We have this, and here's how we get it. So it's going to have 2 rows and 3 columns. So we need to figure out each of the elements of this matrix. So we'll start with the first row, first column. Okay, that spot right there. So this is the first row and the first column. So what we're going to do is we're going to take the first row of the first matrix and the first column of the second matrix, and we are going to multiply corresponding elements and add them up. So what we're going to do is we're going to take this 1, multiply it by this 1. Okay, so we'll do 1 times 1 plus this 0 times this 0. Okay, so plus 0 times 0 plus this 3 times this 4 plus this -1 times this -2. Okay, now this, we still have to simplify this, but this is all just for one element of the result. Now we have to do 2 more on, 2 more on this row, and then we have to do the second row. Okay, so maybe I should move this. All right, so now we can work on the second element in the first row. So we're still in the first row, so we're still going to be using the first row of the first matrix. Now we're going to use the second column of the second matrix. Okay, so because we're working on the first row, second column. First row, second column. So we use the first row of this matrix, and we use the second column of this matrix. All right, so we're going to, again, multiply corresponding elements and add them up. By the way, each element, what we're doing for each element is we're finding the dot product. If you've heard of that term, maybe you've heard of it, but it doesn't matter. 1 times 2. Okay, that's this 1 times this 2 plus this 0 times this 1 plus this 3 times this 3 plus -1 times 1. So it's -1 times 1. Okay, we still have to do one more element on this line. All right, so now we are done with. All right, so we're still working on the first row, but now we're in the third column. So we're gonna take this column. You don't have to actually circle it. In fact, probably it's not a good idea to actually circle it like on a test, because unless you have a pencil, because it's gonna be, if you can't erase it, it's gonna be pretty confusing. So we're doing 1 times -1 plus 0 times 1 plus 3 times 0 plus -1 times 0. All right, so that's the end of the first row. And then we have a second row. Okay, so remember, it's going to be a 2 by 3 matrix that we get here. Again, because that's the 2 and this 2 and this 3. So we need 2 rows, 3 columns. So we have the first row. Now we got to do the second row. So now we're done with the first row of this, and we're done with, we are done with this. So now we are going to do the second row. We're going to use this second row, and we're going to use this column here. So we do, let's see, 2 times 1 plus 0 times 0 plus 1 times 4 plus 5 times -2. Okay, great. Next, we are still in the second row, but now we're doing the second column. So we do 2 times 2 plus 0 times 1 plus 1 times 3 plus 5 times 1. All right, and then we are done with this column, and we are going to, we're still on the second row, but now we're going to the third column. So we're doing, let's see, 2 times -1 plus 0 times 1 plus 1 times 0 plus 5 times 0. All right, now we have to simplify. So what are we going to do? Well, that's just arithmetic. So that's going to be, so we're going to do 1 plus 0 plus 12 plus 2, and then we're going to do 2 plus 0 plus 9 minus 1. Then we will do -1 plus 0 plus 0 plus 0. Okay, and then for the next row, we will do 2 plus 0 plus 4 minus 10, and then 4 plus 0 plus 3 plus 5, and finally -2 plus 0 plus 0 plus, oh, plus 0 again. All right, so now the final step, final step of simplification. Just add it. So we've got 15 and we've got 10 and we've got -1 and we have, let's see, we have a 6 minus 10, so that's -4, and we have 4 plus 8, that's 12, and -2. Okay, I may have made some arithmetic mistakes here. Forgive me if I have, but I think we get the idea. Okay, so let's give the formal definition of matrix multiplication. All right, so now I'm going to give you the definition. You don't have to remember this definition, and it's not easy to understand the definition necessarily, but you need to be able to do matrix multiplication. You don't have to remember the exact definition. You don't have to be able to recite the definition, but here it is. Okay, so let A be an m by n matrix, and so that's A, and let B be a n by p matrix. So why am I using this new number? Well, the thing is, in previous definitions, we had n by n, and usually the other one was also n by n. Here, we just need the number of columns of the first matrix and the number of rows of the second matrix to be the same. But m and p could be different, right? As in the previous example, right? In this example here, we had a 2 by 4 matrix and a 4 by 3 matrix. So, and we're able to do the multiplication because this 4 is the same as this 4. Okay, so again, so we have these two matrices, A and B. Then A times B, okay, is going to be a new matrix. And what's the order of that matrix? It is going to be m by p. Is an m by p, whoops, is an m by p matrix, which we'll call C, where, so now we have to give the formula for each element of C. So where little c sub ij is equal to what? Well, it's a I1 plus B1J plus AI2. Oops, sorry, this is not plus. This is I'm sorry, this should be multiplication. Oops, let's try this again. So so this is AI1 times B1J plus AI2 times B2J plus dot 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 all the way through plus AIN times BNJ. And we can actually write this using summation notation. So each element of the new matrix, Cij, is the sum. So notice, what is this? This is the sum of a bunch of products. That's what we were doing in the previous example. Okay, it's the sum from k equals 1 through n of A sub ik times B sub kj. Okay, let's do another example. And actually, before that, so we said here that we did a 2 by 4 matrix multiplied by a 4 by 3 matrix, and that worked, and that produced a 2 by 3 matrix. How about if we would have tried taking these same matrices and multiplying them in the opposite order. Okay, so if we would have done 1, 2, -1, 0, 1, 1, 4, 3, 0, -2, 1, 0. And multiply, we want to multiply it by 1, 0, 3, -1, 2, 0, 1, 5. Okay, so this is a 4 by 3 matrix, and this is a 2 by 4 matrix. Well, these two numbers are not the same, so this matrix multiplication is undefined. Okay, so this is, it's obviously very different from multiplication in multiplication of real numbers or multiplication of integers, where first of all, if you can do a times b, you can definitely do b times a, and they always produce the same answer. And here you can't even, if you can do a times b, there's no guarantee that you can even do b times a. Forget about getting the same answer. Sometimes sometimes you can't even do b times a, as in this example, where we can do a times b, but we cannot do b times a. Whoops, b times a. So that's an important thing to realize. And let's just do another example of matrix multiplication. So let's try this. Let's try this matrix. 1, 0, 3, 2, -5, 1. Okay, so this is a 3 by 2 matrix. And I want to multiply it by the following matrix, 6, 1. Okay, so first of all, this kind of looks like something else, right? This looks like n choose k. But unfortunately, mathematicians don't have so many symbols at their disposal, or they aren't creative in coming up with new symbols. So this unfortunately looks like n choose k, but we can see it's not n choose k because we're multiplying a matrix by another matrix. We couldn't be multiplying a matrix by n choose k, even though we, if this would be in the opposite order, right? If we'd be doing this times this, then you might think maybe it's scalar multiplication, and that could be a possibility theoretically. But anyways, we don't have to worry about that. And so let's just make sure this is a 2 by 1 matrix. Okay, so this multiplication is legal. It's possible to do this. It is defined. And what is going to be the size of the resulting matrix? Well, it's going to be a 3 by 1 matrix. So that means it's going to have 3 rows and only 1 column. Okay, so it's going to have 3 rows. Now, for the first row, first column, we're going to take the first row here and the first column here. There's only 1 column, but that's fine. So we're going to do 1 times 6 plus 0 times 1. Okay, we're done with the first row because, again, we need to make a 3 by 1 matrix. So it's going to have 3 rows and only 1 column. All right, next we take this row and this column. So we have 3 times 6 plus 2 times 1. And then finally we take this row, this column. So we have -5 times 6 plus 1 times 1. And then we simplify. So we have 6, and then we have 20, and then we have, let's see, this is -30 plus 1, so that's -29. Again, please forgive any arithmetic mistakes, but I think this is the answer. Okay, two little notes. Two little notes, not really, well, they might come up in the homework. So one thing is that a squared, if I have something like this, that means the same thing as saying a times a. So obviously that works. We know we all know this for multiplication of real numbers, or but this also is the same notation used in multiplication of matrices. So if I have a matrix A and I want to multiply it by itself, so I can say a times a, or I can just write a squared. Okay, so that's one point. And then another point, which has nothing to do with multiplication per se, is there's a special matrix that's only filled with zeros. Well, they're actually many matrices that are only filled with zeros. So we write that with using a bold zero. So you'll see like a bold zero, and often we give the order. So we'll say like a bold 0, 3 by 3. So that means a 3 by 3 matrix that has only zeros. Okay, but sometimes we don't bother writing this 3 by 3, and we just say 0 in bold. And we can do that in a case where the dimensions are clear, where the order is clear. So based on the problem, sometimes it's very clear what the order of the matrix is. So in that case, we might drop off these subscripts. So that will come up probably in the homework as well. All right, one more video and that will be it. Well, actually, I wanted to do one more example because it's an important point that I didn't mention before. So let's say I do this 1, 2, 3, 0 multiplied by 2. Well, let's say -1, -2, 0, 1. All right, so we do this multiplication, and I won't bore you with the steps. All right, so we get this matrix as a result. Okay, now how about if we want to multiply these same two matrices, but in the opposite order? First of all, is that possible? So this was a 2 by 2 matrix, and we were able to multiply by a 2 by 2 matrix because these inner numbers were the same, and we got a 2 by 2 matrix as a result. Now, suppose we want to, again, multiply these same matrices in the opposite order. Yeah, it should be fine. So we're going to do -1, -2, 0, 1, multiplied by the matrix 1, 2, 3, 0. Okay, so again, I won't bore you with the steps. And we get this result. Now, notice, obviously, these two matrices are not the same. Okay, so this is very important. Here we did A times B. It was legal, and we got a result. Here we did B times A. It was also defined, and we got a result. But A times B is usually not equal to B times A. So there are some cases where they could be equal. I mean, if both matrices just have zeros, then obviously A times B is going to be B times A. But in general, A times B is not equal to B times A when we're talking about matrix multiplications. This is a very important point to realize. So this is an important difference, right? So in other words, we can say matrix multiplication is not commutative, right? So we know that, if I have real numbers, B times A is going to be A times B because multiplication of real numbers is commutative. Commutative, meaning the order in which I do them doesn't matter. But that's not true for matrices. So very important to realize. All right, and now there will be one more video.